let's talk about ray optics, the branch which actually deals with light, the propagation of light, the way of light, the path of light. So that branch is called ray optics. Okay, so this is the introduction of light and ray optics. So as you see, optics diffusion, the branch of physics dealing with the study of light and its behavior, it's called optics. And as we all know, remember, light travels from light travels in a always light travels in a straight, light travels in a always in a straight path. Okay, so actually we get light in a form of energy. So remember, and always remember, the speed of light in vacuum, when the medium is vacuum, the speed of light is always 3 into 10 to the power 8 meter per second. Okay, now let's talk about the phenomenon of lights, different types of phenomenon. First one is reflection. First phenomenon is reflection. Then after reflection, we will get refraction, and so sometimes we get the dispersion. Okay, so these are some phenomena of light. Now let's talk about reflection. Okay, so reflection of light. Okay, so when light goes and it coincides with a surface, okay, so it gets bounced back. Okay, so that phenomenon is called reflection. When light gets bounced back by surface, then it's called reflection. Okay, so in reflection we get two laws, light follows two laws in reflection. Okay, first one is angle of incidence and angle of reflection are always equal. Now let's see what is angle of reflection and what is angle of incidence. Okay, so okay, so let's say this is a surface. Okay, commonly we use for reflection, commonly we use mirror as a surface. Okay, so this is a mirror, m dash is a mirror. Okay, now let's say there is a source here. Let's say it's a bulb. Okay, light bulb. Okay, light is coming from the bulb. Okay, so the ray which is coming from the source. Okay, so this is called incident ray. Okay, and after, when the incident ray coincides with the surface or the mirror, it gets bounced back, or we can say it's get reflected. Okay, now on the surface, if we draw a normal, on the surface if we draw a normal, the incident ray is making a angle. You can see the incident ray is making an angle with the normal. This angle is called angle of incidence, angle of angle of incidence. Okay, and after a reflection, the refracted ray makes an angle with the normal. Okay, the reflected ray makes an angle with the normal, as and this angle is called angle of reflection. Okay, so we denote angle of incidence as I and angle of reflection as R. Okay, and by the law of reflection, we always get that angle I is always equals to angle R. This is the first, and the second law is the incident ray. This is the incident ray, the reflected ray, and the normal to the surface is always lie in the same plane. Yes, this is the second law of reflection. It has been written here. Incident ray, reflected ray, and normal all lie in same plane. Okay, done. So now the reflection of a object, we always get an image. Okay, now image can be two types. We get two types of images. So one image can be real and another is virtual. Okay, real image is that the rays after reflection, the rays coincide in a point. Okay, if they coincide in a point, then at that point we get real image. Okay, after reflection, let's say two rays are going. Okay, and after reflection, the reflected ray gets coincide at a point. Okay, then at that point, the image which we will get will be real. Okay, and the image which is not actually real, like what you can say, that the after reflection the rays not get coincide really. It it appears to coincide, but it's not coinciding in a real form. Okay, it looks like that they are coinciding, but they are not. Then at in this case we'll get virtual image. Okay, we'll go talk about virtual image and real image. You will go to understand. Okay, done. Sorry. Okay, now, okay, now while we are talking about reflection, to get uh, reflect the light get reflection, we need uh, while talking about reflection, we need to talk about mirrors. Okay, so we get two types of mirror. Okay, one is one is plane mirror and another is spherical mirror and another is spherical mirror. Okay, so the plane mirror is the normal mirror which we use in our home. Okay, in our daily life to see ourselves. Okay, so that's a plane mirror. Okay, the main thing is the spherical mirror. Okay, the spherical mirrors are a part of a sphere. Okay, spherical mirrors are part of a sphere. Done. So in spherical mirror we get two types of mirror. Okay, one is concave mirror and another is convex mirror. Okay, spherical mirror is a, let's say this is a sphere. Okay, and we cut the sphere here and here. Okay, so we get one surface like this and one surface like this. Okay, now if we polish or paint in one side of these parts, okay, let's say we paint in this part, okay, let's say paint in this surface, we paint in this part, and in this surface we paint in this side, so it will become a spherical mirror. Okay, this side is reflected reflecting side, and this side is painted side. Okay, for this mirror, this side is reflecting side, and this side is painted side. Okay, so now they becomes they become mirror. Okay, so when the reflecting side is inwards, okay, in this surface the reflecting side is inwards, okay, inwards, then we call this as concave mirror. And if the reflecting side is outwards, we call this mirror convex mirror. Okay, done. Okay, uh, okay. So there are some applications of these type of mirrors. Okay, okay. Before going the applications, let's talk about another thing. For concave mirror, okay, if the rays are converging in after reflection, in concave mirror, after reflection the rays get converse in a point. Okay, rays get converse in a point. So that's why concave mirror is also called converging mirror. Okay, and the point where the rays get coincide or converge, that point is called focus. Similarly, for convex mirror, the after reflection the rays get deviated. Okay, okay, the rays get deviated after reflection, the rays get deviated from a point, and it deviated from the reflecting surface, and it looks like that it is deviating from a point inside the mirror. It's not really actually deviating from that point, but if we extend the reflected if we extend the reflected rays, it looks like that it the rays are get deviated from a point, and this point is called focus of the convex mirror. And since the rays are get deviated, or the rays get diverged, so that's why we call convex mirror as diverging mirror. Okay, so it shows diverging action, and concave mirror shows converging action. Okay, now let's talk about some applications. So these are some applications. Concave mirrors are used in vehicle headlights, since okay, since light converges in a point, so that's why it uses in vehicle headlight. Solar cookers, okay, and the convex mirror are used in rear view mirrors. Okay, since in convex mirror we get a wide field of view. Okay, so that's why it is used in a side mirror, as it is used as the side mirror of vehicles. Okay, so yes, we get the wide field of view. Done. Okay, remember, convex concave equals to concave like cave-like structure, since it is inwards. I already said it is inwards, and convex is like vexed structure, since its reflecting surface is outwards. Okay. Next. Okay. So there are some rules for ray diagrams. Okay. Before for mirrors, we have to draw ray diagrams, and these are some rules for ray diagrams. So always remember the incident light which goes parallelly through the. Okay. So before going to let's before going to the rules, let's get some point. So here you can see here these are some letters. Okay. So here F denotes, I already said F denotes focus. Focus where light gets converged, or light gets if light gets to be light gets to appear to be diverse from the point. The lights which are di which are getting diverging from a point, it will call focus. Okay. Where the lights are getting converged or appears to be diverse. Okay. Those points are called focus. Okay. And C is center of curvature. C is center of curvature. Okay. So as I said, the spherical mirrors are a part of a sphere. Spherical mirrors are part of a sphere. Okay. So obviously the sphere has a center. Okay. So that center is called center of curvature, and it is denoted by C. Okay. Now let's say let us go to the rules. Okay. So first rule is and okay. The okay. Before going to remember the midpoint of the mirrors. These are the midpoints of the mirrors. This point is called P is called pole. Okay. P is called pole, and the point and the line which joins P and C, center of curvature and pole, is called principal axis. Principal axis. Okay. Okay. Now the rays which are the incident rays which are parallel to the principal axis. Okay. You see the first diagram, which are parallel to the principal axis. After reflection, they go through the focus. Okay. They go through the focus. None. Or okay. Second rule is that if the incident ray goes through the center of curvature, after reflection, it get reflected through the same path, the path which it get reflected through C also. While incident ray is going through C through center of curvature, the reflected ray goes also through center of curvature. That means it follows the same path. Okay. And the rays, incident rays, which are going through focus. Okay. The rays which are going through focus after reflection, the reflected ray goes parallel to the principal axis. Okay. The reflected ray becomes parallel to the principal axis when while incident ray goes to the focus. Okay. Done. Okay. Okay. So these are some ray diagrams. Okay. So these are some ray diagrams of concave mirror. Okay, concave mirror. So number one is when we place a object in an infinite distance from the concave mirror. Okay, so then the image forms at focus. When the position of the object is at infinity, image forms at focus, and the image is real, image is inverted. Okay, image is inverted, and its size is point size. Okay, the second one is when we place an object beyond C. Okay, this is center of curvature. Beyond center of curvature, we have placed the object. Okay, then the light rays go through the one light ray is going, the rays which are going parallel to the principal axis, it gets reflected through focus. Okay, it gets reflected through focus, and the rays which are going through C through C, it is following the same path. Okay, and the light rays which are going through focus after reflection, the reflected ray becomes parallel to principal axis. Okay, now we can see that all the rays have coincide at a point. Okay, at that point the image will be formed. For this object, image will be formed here. Okay, here. So you can see when the position of object is beyond C, we get image between C and F. We get image between C and F. Okay, and the image is, you can see, image is inverted. Image is inverted, and image is real. Image is real. Okay, and image is diminished, or we can say that image, the size of the image is smaller than the object size. Okay, the case 3 is when we place object at C. Okay, I have showed you how to draw the rays. Okay, so when we place the object at C, we get image also at C. Okay, the image will be, as you can see, image is real. Image is real. Image is inverted. Here, image is inverted, and the size of the image is same with the size of the object. Okay, and the images which are formed in front of the mirror, in front of the, since the image is formed in front of the mirror here, before the in the case 2, in the case 2 also, the image is formed here. Okay, be, beyond the reflecting surface or the beyond the mirror, or in the first case the image is also formed at beyond the mirror. Okay, so that's why these images are real image. Okay, and the virtual image, I will show you the virtual image. The virtual image will be formed inside the mirror. Okay, not in front of the mirror, it will form inside the mirror. Okay, that image will be called virtual. Okay, now see in the case 4. Okay, when the mirror is between C and F, center of curvature and focus, when the object is between center of curvature and focus, the image is formed at the image is formed beyond C. Image is formed beyond C, and the also this image will be real since it has formed in front of the mirror. It is real, and as you can see, it is inverted, and the image is enlarged. Image is larger than the object. Okay, done. So see one fact, that as the image is approaching towards the mirror, sorry, as the object is approaching towards the mirror, first, in the first case we have placed the object at infinite distance, then we have placed our object beyond C. Then we have placed between C and F. Yes, center of curvature, between center of curvature and focus. So as the image object is going towards the mirror, the image is going away from the mirror. Remember the fact. Remember that the fact that as the image object is going towards the mirror, the image is going away from the mirror. Okay. Okay. Remember the fact when the when the object is at C, the image is real and C and will be also same size. Okay. This is the case 5, object at focus. Okay. So when the object is placed at the focus, as I have said, when the object is going towards the mirror, the image will go away from the mirror. Okay. So when the image is at focus, object is at focus, image will be at infinity. Okay, it will get highly enlarged. The image size of the image will be very large than the object. Okay. Now see the case 6. When the image is sorry, not this shouldn't be here. Okay. When the object is between focus and pole, here the object should be here. Okay. Correct this. Okay. This should this is okay. So when the object is between focus and pole, I have introduced the pole. Okay. So when the object is between focus and pole, now see the image forms inside the mirror. It will not form in front of the mirror. Okay. It will form inside the mirror. Okay. Then this image will call virtual image. Okay. Virtual image. And as you can see, the image is erect and it is enlarged. Okay, it is larger than the object. This is the image, this is the image, this is the object. Okay, the image is larger than the object, and the since image is formed inside the surface, inside the mirror, so it is virtual. Okay, okay, uh, these are some applications. Dentist and saving mirrors are used in the use the case 6. Okay, dentist and say the barbers use the case 6 because here we get an enlarged image and a erect image. Okay, we have to see the erect image. We can't deal with a inverted image. Yes, so we have to deal with a erect image. So that's why they use case 6. Okay, now these are some the these are some ray diagrams of convex mirror. Okay, so always remember, for convex mirror the image is always virtual. Okay, image is also always virtual for convex mirror. Okay, so and the size of the image is always diminished. It is always smaller than object. Okay, okay, as I told you, in cars we need wide field of view. Okay, to see what are coming, uh, back to backside of our car. Yes, so we need a wide field of view. So that's why convex mirror is used as a side mirror in vehicles. Okay, since in convex mirror we get a wide field of view. Okay, then okay, so there is a mirror formula. Okay, now let's come to the mirror formula. Okay, so let's say this is mirror. This is mirror. We have placed an object here. Okay, and we get uh, image. Let's say we get image here. We'll get a image of this object. here. Okay. Now, always remember while doing the numericals or while calculating the object distance, the distance of the distance is calculated always from the pole of the mirror. The distance is always calculated from the pole of the mirror. Okay. Let's say we have to calculate the object distance, where the object is situated. Okay. How far is the object from the mirror? So then we have to calculate the distance, okay, from pole. Or we always calculate the distances from pole. Remember that. And the distances which are calculated towards left side of the pole, those distances are always negative. Okay. And the distances which are calculated right side to the pole, okay, right side to the pole, that is always positive. Done. And the distance which is calculated upwards to the pole is positive, and the distance which are calculated downwards to the pole is always negative. Remember this. And this is called Cartesian sign convention. While doing the numericals, we need this sign convention. Okay. I am saying again, the distances are calculated always from the pole. The distance which are calculated right side to the pole is always positive. The towards left side from the pole is always negative. Towards upside it's positive. Towards downside it's negative. Okay. Now we always denote the object distance. I have already told. Then we have to calculate the distances from the pole. Okay. And the object distance is always denoted by capital small u. Okay. The image distance is always denoted by small v. And the distance between the pole and the focus. Okay. I have told you about the focus, where light gets convert or appears to be diverse from the point. Okay. So distance from pole to that focus is called focal length, and it is denoted by small f. Okay. And these are correlated by a formula called mirror formula. It is 1 by f equals to 1 by f equals to 1 by u plus 1 by 1 by u plus 1 by it is called mirror formula. And while calculating the distances, always use this sign convention. Okay. And always remember that object distance is always negative, since we place object always to the left side of the mirror. Okay. So that's why object distance is always negative. Remember this. Okay. We have written here that object distance is always negative. Yes, always remember that. And while calculating, always use sign convention rules. Okay. Okay. So okay. So this is all about reflection. Okay. In the next video, we will discuss about another phenomenon of light, which is called refraction. Okay. We will discuss it later in another video. Okay. And now, hope you have learned about reflection. Okay. Thank you.